welcome. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today, eventually, we're going to go on and cover the second part of section 8.2. But before we do, I want to remind you of a couple of things, and then we'll take a look at a question that was requested, and then we'll go on. So first of all, the following is true. 0 divided by a non-zero number, that means hashtag now, but it also meant number long ago, is equal to 0. So 0 divided by -10 equals 0. 0 divided by 3,000 equals 0. 0 divided by anything that's not 0 equals 0. Okay. Secondly, if you have a non-zero number divided by 0, that is undefined. Okay. There's a t-shirt that says it's all fun and games till you divide by 0. Anyway, dividing by 0 is undefined. 0 divided by a non-zero number equals 0. I bring this up because in the examples we're going to look at here, these two answers come up. First of all, this is number 21 from 8.2 part 1. It says h of x equals x squared plus x minus 2 over x squared minus 7x. Let's find h of 7. So that would be 7 squared plus 7 minus 2 over 7 squared minus 7 times 7. Let's see. 7 squared is what? 49. 49 plus 7 is 56. 56 minus 2 is 54. 7 squared is 49 minus 7 times 7, 49, 0. 54 divided by 0 equals undefined. Now, the student that requested this actually wrote that answer, but that's not the final answer. Undefined is the final answer. Then we have h of -2, which would be -2 the quantity squared plus -2 minus 2 all over -2 the quantity squared minus 7 times -2. -2 the quantity squared is 4. 4 plus -2 is 2. 2 minus 2 is 0. -2 the quantity squared is 4. -7 times -2 would be a positive 14. And so we get that, which is equal to 0. So your final answer is undefined and 0. Any questions about that before we go on? Okay, well then let's go on to section 8.2, part 2. We talked yesterday about domain and range, and we said that domain was the input or the independent variable or the first coordinate or the x values, and the range was the y values or the output or the dependent variables or the second coordinate values. Anyway, we've got some problems where it says, find the domain of each function. Also, we're going to be using interval notation, which some of you may have learned and forgotten. If you want a big refresher, back in section 2.7, I believe it is. Let's see here. 2. Helps if I had my glasses. Yes, 2.7 is where you could get a full review of that. We'll do a little bit here, and if you need more, let me know. But otherwise, 2.7 is where it is in the textbook. Okay, so our first question, again, it says, find the domain of each function. And we have the following. H of x equals 3x plus 6. I want to actually go back to this situation, okay? Given this function 7 is not in the domain of the function because when 7 goes in, undefined comes out. The domain of the function would be all of the inputs that produce a real output. So if you put something in and the result is undefined, that input is not acceptable. It's not in the domain. Okay, so now let's go back here. H of x equals 3x plus 6. In this section, the main thing we need to avoid, is dividing by 0. If an input value makes the whole thing such that you're dividing by 0, that input gets booted from the domain. Now, h of x equals 3x plus 6. There is no number for x that we could put in that would make this thing undefined. So the domain is all real numbers. Now, how do we say that in interval notation? We have the set of all numbers going from negative infinity to positive infinity. The parentheses on each end imply that it's open, it continues. Negative infinity is to go on the number line to the left forever. Positive infinity is to go on the number line to the right forever. So there's no specific endpoints. So the domain for this function is all real numbers, but written in interval notation, it would look like that. Any questions on this problem at this point? Okay, let's take a look at another problem. This says f of x equals 1 divided by x minus 4. Now recall, the thing we want to avoid is dividing by 0. So the question is, when would the denominator of this fraction be 0? Well, let's take the denominator, set it equal to 0, and then solve it. Let's see. If we added 4 to both sides, we would have x equals 4. So when x is 4, the denominator is 0, and the function is undefined. So x equals 4 is the bad guy. That's the one we want to kick out. So the domain would be all real numbers except x equals 4. Now, how would you say that in interval notation? So I want all real numbers except 4. So what I'm going to do is I'm going to go from negative infinity up to, but not including 4, along with everything after 4 going up to positive infinity. So this symbol is a union symbol. It means that we have all of that along with all of that. When there's parentheses, you do not include that endpoint. If I had this, for instance, that would say everything from negative infinity up to and including 4. But we want to exclude 4, so that's why we use the parentheses. Any questions there? Okay, let's take a look at this problem. Let's see here. F of x equals x squared. Any real number I put in there for x and square it, I'll get another real number. There's no denominator, so there's no way it's going to be dividing by 0. So the domain, again, would be all real numbers. Let's see here. S of x equals 9 divided by 2x plus 1. Here we have a variable in the denominator. So let's take the denominator and set it equal to 0. Solving for x, we get x equals -1/2. So for instance, s of -1/2 would be 9 over 0, which is undefined. So I want to throw out -1/2. So the domain is going to be from -infinity up to, but not including -1/2, in union with after -1/2 up to +infinity. So here's the domain written in interval notation. Any questions about that one? All right. Next, we're going to look at some graphs. And we're going to review, actually, before we do that, let's review the whole idea of slope intercept form, which is y equals mx plus b. So if you have an equation that is solved for y, and you write it in the form y equals whatever the coefficient of x is times x plus whatever constant there is, m is the slope of the line and b is the y-intercept. That is the point where the graph cuts through the y-axis, okay? A lot of what we're going to be looking at today, again, goes back to chapter 3. So I'll be introducing rules, but if you want an extensive review of them back in chapter 3, again, or you can ask me, but if you want on your own, chapter 3 is where all this material is coming from. Okay, so let's take this equation. F of x equals 2x minus 1. That's the same thing as y equals 2x minus 1. So using slope-intercept form, y equals mx plus b, and this function and equation is in slope-intercept form. Slope is 2, and the y-intercept is -1. Now, 2, there's an implied 2 over 1. So I've got the slope and the y-intercept. So I'm going to begin at the y-intercept, which would be the point 0, -1, which is right here. And then we're going to move from left to right, going up 2 and over 1, up 2 and over 1, etc. Okay, using the slope that is up 2 and over 1. Okay. So here is the graph of f of x equals 2x minus 1. Any questions on this example at this point? All right, here's another one. F of x equals -x plus 2. This is the same thing as y equals -x plus 2. So using y equals mx plus b, the slope is -1, because recall there's an implied 1, so the coefficient is a -1, and the y-intercept is 2. So we're going to start at 2, and then the slope is going to go down 1 and over 1, down 1 and over 1, down 1 and over 1, as it goes from left to right. And there is the graph of f of x equals -x plus 2. Any questions on that one? Okay, let's take a look at, let's see, this one. F of x equals 2/3 x minus 2. So here the slope is 2/3 and the y-intercept is -2. So we start at a y-intercept of -2. We go up 2 and over 3, up 2 and over 3. And here's the graph of f of x equals 2/3 x minus 2. Okay, how about this one? This says f of x equals 2. So that's like y equals 2. Well, and here is something from chapter 3. When you have an equation in the form y equals a constant, that is y equals a number, that is going to be a horizontal line. Okay. Now, if we think of this as y equals 0x plus 2, the slope is 0 and the y-intercept is 2. Well, the slope of a horizontal line is 0. Okay, so what would I do? I'd start here and I'd go up 0 as I go over. And so what I get is a horizontal line. Oops. Going through y equals 2. Okay, so a line in the form y equals a constant is a horizontal line, and the slope of a horizontal line is 0. Any questions there? All righty, one more. Let's see, we've got g of x equals negative 0.25x. Well, g of x is another name for y. Negative 0.25 would be negative 1/4. Okay, so the slope is negative 1/4. The y-intercept, it's like there's a plus 0 out here, so it would be 0. So this graph goes through the origin. Here's the y-intercept. We're going to go down 1 and over 4. So this is the graph of g of x equals negative 0.25x. All right. Again, any questions concerning slope-intercept form and graphing using that form? Okay. Now we're going to go to some problems where we won't be graphing, but we'll be writing an equation for a linear function. And typically, we write that in the form f of x equals mx plus b. So we'll see how that goes. All right. It says, write an equation for a linear function whose graph has the given characteristics. The slope is 5, and the y-intercept is at 0, -3. I can write this using shortcut notation and say the slope is 5. Recall that m stands for slope, and the y-intercept is -3. B stands for the y-intercept, and you only list the y value. So now, taking this information and putting that there and that there, I get f of x equals 5x minus 3. So that would be a function that has a slope of 5 and a y-intercept of -3. Okay, any questions on that one? Let's take a look at this one. This one has a slope of 1/5 passing through the point 10, 1. So the slope is 1/5. However, 10, 1 is not the y-intercept. So to get into this form, I need m, the slope, and I need b, the y-intercept. Well, I have the slope, so that's going to go right there. Y equals 1/5 x plus b. I do not yet have the y-intercept. However, I do have an ordered pair that's on the line where the x value is 10 and the y value is 1. So I can take the 10 and put it in for X and the 1 and put it in for Y. And I get the following information. 1 equals 1/5 times 10 plus B. 1/5 times 10 reduces down to 2. Subtracting 2 from both sides, B equals -1. So now I've got the slope and the y-intercept. So y equals 1/5 x minus 1, writing it as a function. F of x equals 1/5 x minus 1. Any question about that problem? Okay. Here, all we're given to find the linear function is it says it passes through the following 2 points, 1, 7 and -2, 1. Well, I need the slope and the y-intercept. I have neither one. However, there's something, and this goes again back to chapter 3, called the slope formula. The slope formula says m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, the subs are subscript, so y sub 2 refers to the y value in point 2. Y sub 1 refers to the y value in point 1. X sub 2, the x value in point 2, x sub 1, the x value in point 1. So I'm going to call my first point, point 1, and my second point, point 2. So then I'm going to fill in the numbers here. So y sub 2 is 1. Y sub 1 is 7. X sub 2 is -2. And x sub 1 is 1. Okay. 1 minus 7 is -6. -2 minus 1 is -3. -6 over -3 is 2. So now I know that the slope is 2. Okay. So starting with y equals mx plus b, the slope goes in there. So y equals 2x plus b. Well, now I can take either one of the original points, point 1 or point 2, plug it in for x and y to solve for b. Now, I can use either point 1 or point 2. I don't want to pick an x from one of the points and a y from the other point. So you got to stick with the same point. Let's go ahead and use point 1. So x is 1 and y is 7. So 7 equals 2 times 1 plus b. 7 equals 2 plus b. Subtract 2 from both sides. B equals 5. So now I know the slope is 2 and the y-intercept is 5. So y equals 2x plus 5, but in function notation, f of x equals 2x plus 5. Let's check our work. Let's make sure that both points are solutions. If x is 1, so f of 1 would be 2 times 1 plus 5, which is 7. So this point checks. F of -2 would be 2 times -2 plus 5, which is -4 plus 5, which is 1. So that point checks. Okay. Any questions there? So we've got the slope formula. Okay, now this says write an equation for a linear function that passes through the point 3, 0 and is parallel to the graph of g of x, g of x equals -2/3 x minus 4. Okay, so another idea from chapter 3 is this. Parallel lines have the same slope. So if line 1 is parallel to line 2, then the slope of 1 equals the slope of line 2. Okay. All right. So since the two lines are parallel, they have the same slope. Looking at this function, it's in slope-intercept form. The slope, the slope is negative 2/3. Therefore, the slope of the line that's parallel, I'm just going to use that for parallel, is also negative 2/3. Okay, so I know the slope of the new line. So y equals mx plus b. The slope is negative 2/3. Y equals negative 2/3 x plus b. The only thing I use from that g of x function is the slope, not the y-intercept, but just the slope. But we also know this line we're supposed to find passes through the point 3, 0. So I can put 3 in for x and 0 in for y. And I get 0 equals negative 2/3 times 3 plus b. The 3's reduce out. 0 equals negative 2 plus b. Add 2 to both sides, and b equals 2. Okay, so my new equation, y equals negative 2/3 x plus 2, writing it as a function, f of x equals negative 2/3 x plus 2. Are they parallel? This line here and this one, they have the same slope. And 3, 0, is that a solution? F of 3 equals negative 2 times 3 plus 2, which is negative 2 plus 2, which is 0. So it checks. Okay, so parallel lines have the same slope. Okay. This says write an equation for a linear function with the following characteristics. It passes through, let's see, 1, 2, and is perpendicular to the graph of g of x equals negative x over 6 plus 1. All right. Parallel lines have the same slope. Perpendicular lines, lines that meet at a right angle or a 90-degree angle, have slopes that are negative reciprocals. So let's say that line 3 is perpendicular to line 4. The slope of 3 is 4/5. The slope of 4 would be negative 5/4. So parallel lines, same slope. Perpendicular lines, the slopes are negative reciprocal. So you're going to take the reciprocal and change the sign. Okay. Now, over here, what is the slope of this line? Well, it's negative 1/6, because keep in mind there's an implied 1. So negative 1 x over 6 is like negative 1/6 x. Okay. So if the slope of g of x is negative 1/6, the slope of the line that's perpendicular would be positive 6/1, or just 6. Okay, so it'd be the negative reciprocal. So the line we're creating has a slope of 6. Okay, so y equals mx plus b. This was just an example. Okay, so 6 is going to go in there. It goes through this point, so we're going to put 1 in for x and 2 in for y. 2 equals 6 plus b, subtract 6, minus 4 equals b. So y equals 6x minus 4, f of x equals 6x minus 4. The slopes are negative reciprocals because the two lines are perpendicular. And let's see here what I want to do next. Okay. Write an equation for a linear function whose graph has the given characteristics. The graph is horizontal and it passes through -8, 12. All right, if it's a horizontal line, it's got to be in the form y equals a number or y equals a constant. But since it goes through the point -8, 12, the y value has to be 12. So y equals 12 or f of x equals 12 would be the solution. Okay, I want to review and add a couple of more items. To find an x-intercept, set y equal to 0. Okay, to find a y-intercept, set x equal to 0. We've got the slope formula, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We've got slope-intercept form, y equals mx plus b. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals. Let's see. Let's go to the next page and you can come back to this if you want. You can come back to it or you can always look at the video. Let's see. And let's see, what do I want to say? Oh, the graph of a line in the form y equals a number or y equals a constant is a horizontal line. Okay, let's see here. Did I do slope intercept form? Yeah, I've got that. I didn't talk about this one, but I'm going to add it to this. The graph of a line in the form x equals a number is a vertical line. Oh, I know what else. The slope of a horizontal line is 0, and the slope of a vertical line is undefined. Now, all of this on this page and this page, they're all back in chapter 3. They're like from Math 85. If you, like I say, you need more review on that, let me know. Come to my office hour, email me, you know, whatever, and I'll be happy to guide you through that. But it is all from chapter 3. Okay, now I want to take a look at an application problem where basically what we're going to do, we're going to read a story and extract information for 2 ordered pairs. Then we're going to go back and use the technique we used earlier in this today, where given 2 ordered pairs, find the equation of the function. Okay, so here's what it says. It says nurses. The demand for full-time registered nurses in the United States can be modeled by a linear function. So we're talking y equals mx plus b, or I suppose you could say f of x equals mx plus b. They're the same form. Okay. In 2005, approximately 2,175,500 nurses were needed. By the year 2015, the number is expected, so this is an old problem, the number is expected to increase to about 2,586,500. Okay, don't worry if you didn't catch all those numbers, I'm going to repeat them. Let T equal the number of years after 2000. So T equals number of years after 2000, and N be the number of full-time registered nurses needed. So number of full-time, I'm going to say nurses, okay, needed. There we go. All right. Write a linear function N of T to model the demand for nurses. All right, so what this tells us several things. T stands for the number of years after the year 2000. So the year 2000, T is 0. The year 2005, T is 5. The year 2025, T is 25. N stands for the number of full-time nurses needed. It says write a function N of T. So that means that T is the input because it's on the inside, and N is the output because it's on the outside. So our ordered pairs are going to be in the form T comma N instead of X and Y. Okay, now let's go back and read it again. The demand for full-time registered nurses in the United States can be modeled by a linear function. In 2005, so for that, time would be 2005, 5 years after the year 2000. In 2005, approximately 2,175,500 nurses were needed. So that's an ordered pair we can extract from the reading. 5 years after 2000, 2,175,500 nurses were needed. By the year 2015, so now T is 15, the number is expected to increase to about 2,586,500 nurses. Okay, let T be the number of years after 2000 and N be the number of full-time registered nurses needed in the US. Write a linear function N of T to model the demand for nurses. So I'm going to take these two ordered pairs and write the function. Now, I'm going to use X and Y because the formulas are written in X and Y, but then at the end I will change the variables. Okay, so I've got two ordered pairs. I'm going to use the slope formula. M equals Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1. Okay, I'm going to call this point 1 and this point 2. Y sub 2 is 2,586,500. Y sub 1 is 2,175,500. X sub 2 is 15. X sub 1 is 5. Okay, so calculator time. 2,586,500 minus 2,175,500 equals 411,000. 15 minus 5 is 10. 411,000 divided by 10, so you'd basically get rid of 1 0 in the numerator, right? Because you'd cross one out, one out. So the slope is 41,100. Okay. Now, using Y equals mx plus b, Slope is going to go in there. So y equals 41,100 x plus b. Now I'm going to take one of the ordered pairs. I'll go ahead and take this one. 5 goes in the place of x. 2,175,500 goes in the place of y. So what do I get? I get 2,175,500 equals 41,100 times 5 plus b. Okay. 2,175,500 equals, let's see, 41,100 times 5 is 205,500 plus b. Subtract 205,500 from both sides, and we get b equals, let's see here, 2,175,500 minus 205,500, 197,000, so 1,970,000. Okay. All right, so I found out the slope was that and the y-intercept was that. Okay, I'm going to take that information to the next page. Slope was 41,100 and the y-intercept was 1,970,000. So that would give me y equals 41,100x plus 1,970,000, but it's supposed to be t and n of t. So n of t equals 41,100t plus 1,970,000. So there's the answer. Now, a common mistake that students make in WebAssign or other places is they change variables. If the problem asks you to have it in t and n and use x and y in your answer, it's going to mark it wrong. So make sure you're using the correct variables in your final answers. Okay, so that was part A. Then it says use your answer to part A to predict the number of full-time registered nurses that will be needed in 2025. So in 2025, T would equal 25. So they want us to find N of 25. Okay, so let's see here. 41,100 times 25 plus 1,970,000. And I'm getting 2,997,500. So 2,997,500 registered nurses. Okay. Any questions on this example? So I know it was kind of long, but basically what we did was we extracted two ordered pairs, used those to find the slope, and then the function, used the correct notation for the function, and we were done. All right. Well, that's all I've got for you for today. I'm sure that's enough. So this is section 8.2, part 2. A reminder, interval notation comes from section 2.7, and all of this material that was here and here comes from chapter 3. If you need a further review, I will be back at 1:15 with an office hour. So have a great rest of the day, and I'm going to stop the recording